Welcome to This Medical Life podcast. These are the stories of medicine with Steve Davis and Dr. Travis Brown.
This is a story about Ricketsias.
Dr. Travis Brown, if we're talking about a topic, a condition, a disease named after someone, rickets, contains rickets in the name but is not rickets, what are you trying to do to me?
It is a bit confusing. The story about Ricketsias is actually a really interesting one we'll get into. But yes, I can understand that there is an unusual sort of terminology which we delve into in medicine a lot. But yeah, we're talking about Ricketsias today, and the interesting part about Ricketsias is when you actually delve into medical history, and we come across this quite a lot, is that you find terms that most people is broad in medical history, but we refine it in time. And this is because this was a disease that was called typhus. But we know a lot of diseases that are called under the banner of typhus. We know Salmonella typhi was named after this typhus, but this was also a typhus, and there's actually many versions of typhus, and this is one of them. And typhus, or what they also called it was typhus fever, was kind of a group of infectious diseases that we've been able to now tease apart and diagnose. But clinically, this was a disease or something someone would present with, and they would have fevers and headaches, and then they would get this rash that would appear about 1 to 2 weeks later after their first illness. And the classic diagnosis today, Rickettsia, is something called Rocky Mountain Spotted Fever, which is actually a United States diagnosis. We don't.
Yes, I'd guess that.
And in Australia, this is termed either spotted fever, or we can sometimes call it Queensland tick fever, or tick typhus, depending. But the first time we encounter this medical description was actually in 1896, and this was Bitterroot Valley of Montana. And they had this mysterious illness. It was called a few names back then. It was called either blue disease or black measles, black typhus, or just fever. But in March 1901 in Montana, they created the State Board of Health, and they began to investigate this disease. Now, they got a group of scientists and doctors, including a Dr. John Anderson, who wrote a report on this investigation. He called it Spotted Fever of the Rocky Mountains, a New Disease.
1. Geographic distribution. Montana. The disease has been known in the valley of the Bitterroot River in western Montana for about 20 years. It is sharply localized on the west bank of the Bitterroot River, no cases having been known to occur in persons on the east side of the river who had not a short time previously visited the west side. The infected locality extends from Lulu to Como, a distance of about 50 miles. Certain places in the valley seem to be more heavily infected than others. 9 cases have also occurred in the canyon of Rock Creek, about 10 miles south of Benito and 20 miles east of the Bitterroot.
They gathered a lot of information about this disease.
The disease has been known clinically in Idaho for many years, the first published description having been made by Dr. E. Maxey. The disease prevails exclusively in the spring and early summer. In the Bitterroot cases, the earliest was March 17 and the latest July 20. All occupations that cause the person to be exposed to the bite of ticks, such as stockmen, and especially sheep herders, miners, prospectors, lumbermen, ranchmen, and those whose duties take them into the brush, are subject to the disease. Spotted fever occurs at an elevation from 3,000 to 4,000 feet above sea level.
And so since 1885, so covering the span of 16 years, they reported 121 cases. Now, the cases ranged in patients from 18 months to 74 years. So this was 76 males, 45 females, and they had detailed notes on these patients. And this is an example of a 43-year-old farmer who got this spotted rash 4 days after his illness onset.
Was called to see this case on July 9, he having been attended by others prior to this, found him entirely comatose and learned that he had existed for 3 days prior. Respirations hurried. Temperature, but slightly above normal, and the petechiae abundant, many of which, by their coalescence, may a spot as large as 1 inch in width and 2 or 3 in length, all of which later on formed dry gangrene and sloughed to a depth including deep fascia.
Now, surprisingly, this patient survived, but the vast majority didn't, and this was the concern. This spotted fever occurred elsewhere, as was mentioned in the report, but that had a mortality rate of around 5%. This Bitterroot Valley version had mortality rates between 70 to 90%. And so this was also referred to as tick fever.
On a closer study of the cases of spotted or tick fever, it was always found that there was a history of tick bites about 1 week before the onset. The usual time between the bite and the onset of the fever is about 7 days. For a few days, the patient may have chilly sensations, malaise, and nausea. Finally, there is a distinct chill, and the person takes to bed. There is some pain in the back and head, soreness of the muscles and bones, causing a sensation as if the limbs were in a vice. Bowels constipated, tongue with heavy white coat, red edge and tip, conjunctivae congested, becoming yellowish, urine usually small in amount, slight bronchitis after a few days, nosebleed, sometimes quite severe, is always present. Before the distinct chill, there is little or no fever in the morning. After the chill, there's an abrupt rise, and from then on the fever gradually rises in the evening with a light morning remission. The maximum is usually reached on the 8th to 12th day, then, in favourable case, gradually falls. In fatal cases, the fever remains high. The rash eruption usually appears on the 3rd day, first on the wrists and ankles, then on the arms, legs, forehead, back, chest, and last and least, on the abdomen. At first the spots are of a bright red colour, macular at all times, from pinpoint to a split pea in size. At first they disappear readily on pressure and return quickly, but if the case is a severe one, they soon become darker and in some cases are almost purple.
Now, there's a number of theories causing this disease, such as parasites or dengue, and they use a whole range of treatments. Clearly don't work, but things like quinine, calcium, whiskey, and they use and they use morphine powder also, but that's for the pain. And look, the report does state seeing these parasites in the blood, and they look like, when they draw them, malaria parasites. Now, that's clearly wrong, but this was a public health approach, and so their approach to this was tick reduction strategy. So they understood it was associated with ticks, and they talked about burning undergrowth and getting rid of forest stubble, and this was particularly prevalent in fall and autumn or in early spring. And this is where Howard Taylor Ricketts enters. Now, he was born in 1871, and he went to medical school in Northwestern University, and he worked in the medical museum. He did an internship in Cook County Hospital, and it led him to something called dermatopathological...
Hang on, no, we're leaving that in. If I've got to do those words, you have to do those words.
Dermatological pathology. So there you go, mixing the words around. Now, he was married and he had 2 children. Now, there's interesting facts that, just pop out to you about his work-study challenges. Now, he was clearly brilliant, but it was just in his biography or is sort of some of the notes, because there's no official biography. He had this, quote, nervous breakdown in third year of medical school, which he recovered from quickly, they say. But a colleague said that he began to study Rocky Mountain spotted fever as a pastime due to an enforced holiday due to overwork. And so there's sort of unusual sort of quirk. But in 1906, Howard and his volunteer research assistant, Russell Wilder, went to Montana, and they went and studied spotted fever. Now, the problem at this time, as we've discussed, this was spanning about 20 years worth of information and disease presentations. And it was a bit of a low time for the disease when he went there. And so he didn't get to see much of the illness in humans. And so he began to study this in animals and in monkeys and in guinea pigs. And he found out that it was actually the wood tick that was transmitting this disease. Now, he believed it was a virus. And he wrote an article about this, and this led to an invitation to study the disease in another location. This was called Tabardillo, and this was Mexican typhus fever. And this was an outbreak happened in Mexico City in 1909 when he was still on an enforced break from work. But Mexico City had over 3 centuries, 22 outbreaks of this typhus fever. And today, it was interesting because they used tree ring chronology to look at what they were seeing, and 19 of 22 of the epidemics occurred with below average tree growth and drought and low crop yields. And so there's a correlation in historical documents that these conditions created these economical refugees that would then move from the countryside into cities. And so this led to a whole bunch of crowding and unsanitary living conditions. And this was what they called, so this tabardillo was also known as epidemic typhus. And it was actually spread through body louse. And so people then crowding in these areas would then get these outbreaks of this body louse spread typhus, epidemic typhus. Now, what Howard Ricketts was studying, he studied and found the microorganism that was being transmitted. And he said it was an apparent bacillus, and it was in patients with tabardillo, and it was in the louse as well. So he recognized the connection. And the problem for him, though, was he got infected with it. And then he ended up dying from this disease as they had recognized it. It was also the same bacteria or the same organism responsible, which we would call Rickettsia now, for the Rocky Mountain spotted fever. And so a few years later, in his honour, it was actually called this type of organism was called Rickettsia after Howard Taylor.
And keeping that theme live, our guest for this episode also might or might not have something named after him within the Rickettsial family. Professor Stephen R. Graves is a medical microbiologist and Fellow of the Royal College of Pathologists of Australasia, the RCPA. Stephen has national and international reputation in the field of tick-transmitted pathogens. Over 20 years ago, he established the Australian Rickettsial Reference Laboratory, ARRL, which specialises in diagnosing infections transmitted by ectoparasites such as ticks, lice, fleas and mites. In Australia, these infections are mainly Rickettsial and Q fever. Stephen was involved in the discovery of Flinders Island spotted fever and has had a new Ricketsia found in the Australian ornate kangaroo tick named after him, Rickettsia gravesi. Is that how it's pronounced, Stephen?
Gravesi, yes.
Yes. Professor Stephen Graves is our guest here on this Medical Life podcast. Welcome
Thank you. It's a pleasure to be here.
Can I start by asking just what are Rickettsia?
Well, simply put, Rickettsia are bacteria, and they're all over the place, but a lot of them live inside invertebrate animals, such as ticks, fleas, lice, and mites. And some of these Rickettsia can actually infect humans when those invertebrate animals actually act as an agent to transmit it to humans by either biting them or inhaling their infected feces or some way. So there's this little ectoparasite that is the intermediate. Now, the thing about Rickettsia that makes them different from other bacteria is that they grow inside cells, other cells, our cells, cells of invertebrates. You can't grow them in horse blood agar. You can't grow them in blood cultures. So if your patient has got a rickettsial infection, the lab, the microbiology lab, won't be able to grow it, because the only way you can grow it is if you've got a cell culture. And they don't use them now. They've gone out of fashion since the molecular revolution. Everybody diagnoses viral infections by PCR. Now, you'll recall viruses are also obligate intracellular microbes. They're not bacteria, of course, but they need cells to grow in. So Rickettsia are like that, and so is Q fever. And so unless you've got that facility in your laboratory, and but virtually nobody has now, you won't grow them. And so rickettsial infections are often not diagnosed by the doctor, the GP, even the specialist infectious disease physician sometimes. And this is the problem because they're so easy to treat.
We're talking about spotted fever, and Rickettsia is associated with this spotted fever presentation. Can you tell us how that comes about? What is the pathogenesis of Rickettsias?
Spotted fever is actually quite common in Australia, especially down the east coast, where the particular tick that carries the particular Rickettsia is actually quite common, especially in the northern suburbs of Sydney, where all the lovely gardens are. And we often see patients who have either been diagnosed or their diagnosis has been missed. Now, as the name implies, the features are fever and spots, i.e. a rash. But if you look carefully, you'll also see where the tick has bitten the patient. So it's often a tick bite. And the other prominent feature of the illness is that they get very bad headaches, muscle pains, and generally feel crook for a couple of days. Now, they generally speaking, the ones in Australia, generally speaking, don't kill you. They're not like some of the overseas ones. And so people often don't go to the doctor if it's mild. The disease is not notifiable, so we don't actually know how many cases there are. It's often misdiagnosed as, you've got a mild viral infection and you'll get over it. And the problem with this is, yes, they will get over it in 99 out of 100 times, but it takes about a week. Whereas a short course of doxycycline, 3 days of doxycycline, and you're better in 24 hours.
It's amazing that we don't know more about rickettsial disease. Is there any non-classical presentations of this? Or there is something that I've read about which is called the eschar. Is that useful to find on someone?
Yes. Yes, the eschar is very helpful because that's the lesion where the tick actually, or not necessarily a tick, it could be a mite or a flea or anything, but it's where the ectoparasite bites the patient. But often you can't see that spot because it's hidden in the hair, it's in the natal cleft, it's under the scrotum, it's under the breasts. And when you're examining patient for an eschar and you start looking in their natal cleft and under their scrotum because they come with fever and a rash, they wonder about you as a doctor. So you have to explain it beforehand. Look, I've got to look all over your body for a site of a tick bite. And in children, it's often in their hair, particularly little girls with long hair. So it's often very hard to find. And probably less than 50% of the time do you actually find an eschar in a spotted fever group infection. And then there's the other form, the murine typhus, where you inhale the bacterium. And there's no eschar at all because it's basically a pneumonic process that gets started.
Is there any hints that a doctor might understand, like going out into the brush of Australia outback, or is there is there anything that actually should trigger kind of, I should look for an eschar or consider Rickettsia?
They're very hard to diagnose because there's no pathognomic feature. There's nothing you can look at and say, ha, that's Rickettsial, or ha, that's Q fever. you've got to actually ask the patient. They've got to have been in a situation where one of these ectoparasites can bite them or they can inhale the feces. So you've got to ask about bushwalking, about being in a rural setting, in regional rural, where you can inhale the spores of Q fever. You've got to ask about rodents. Have you been in a dirty shed where flea? So it's not the rodent feces that is infectious, it's the feces of the flea that lives on the rodent. So you've got the rodent, then you've got the fleas on the rodent, then they excrete huge volumes of Rickettsia. So if you're cleaning up around your shed and you inhale the feces of the flea, you can get what's called murine typhus, and we've seen and you can be quite sick with that as well. But again, the mortality is it's quite low in Australian Rickettsia. The overseas ones like scrub typhus and Rocky Mountain spotted fever and epidemic typhus, which we see occasionally in return travellers, they are quite dangerous with mortalities of 20-30% if they're not diagnosed and treated. And treatment with a rickettsial infection is often problematic because the doctors tend to use beta-lactam antibiotics if they don't know. So they get a patient with a fever. They may or may not have a rash. They may or may not have an eschar, but they feel crook. So they give them a penicillin-based drug or a cephalosporin-based drug. And unfortunately, the Rickettsial cell wall is such that it doesn't respond. So they don't get better. If you give a doxycycline, and this is the take-home message, really, if you've got a patient with a fever, especially if they've got a rash, especially if they could have been bitten by something, give them a short course of doxycycline as well. It's a very innocuous drug. It's really cheap. You only need to give it for a couple of days, and the patient will be so appreciative because they'll be better in 24, maybe 48 hours.
Stephen, before you joined us, we were looking at the history of Rickettsia, and there was talk in the early days of miners, lumbermen, etc., being pretty much prey to this. Here, you're suggesting people who are doing yard cleanups, garage clean-outs, gardeners would be in areas. That's the sort of thing that should also be included on the radar.
Yes, absolutely. They're the people that GPs will see. People that work in their garden a lot. In the northern suburbs of Sydney, for example, people have nice gardens and they spend a lot of time gardening. And there's a tick up there called Ixodes holocyclus, which carries Ricketsia australis and sometimes Ricketsia honii, two species of Rickettsia. And they have got quite a high proportion of Rickettsia in them, and people get bitten. So it's not the exotica, it's not the rickettsial diseases that have changed nations, changed histories, like Napoleon's troops when they were fleeing from Russia after his failed invasion. 90% of them died of typhus, epidemic typhus. Sorry, probably some of them died of the cold as well.
Yeah.
But most of them didn't die of Russian bullets. They died of typhus. And of course, it has influenced history. The gentleman who discovered the first Rickettsia, and that's a chap who they're named after, Ricketts, he actually died of rickettsial infection, the poor man. So there are some very nasty ones. The nastiest one in Australia probably is the one that we don't see very often. It's up in tropical Australia called scrub typhus, and that has a relatively high mortality rate, 10 to 30% if not treated. And it was a big problem in World War II with Australian and American troops fighting in Papua New Guinea. There was a lot of scrub typhus. And in those days, we didn't have doxycycline either.
So there's still a bit of the remnants of calling this typhus and actually staying that. Which areas of Australia are we concerned about for people and consider rickettsial infection?
Basically all over Australia. Because murine typhus, the one that you get by inhaling the infected flea feces, can be found anywhere in Australia. All right. So any doctor in Australia should know a smidgen about rickettsial infections and know to treat them with doxycycline. They're all typhus. They're all a type of typhus. The other important ones in Australia are the spotted fever group infections, which we see down the east coast, the ones we've been talking about in the leafy suburbs of northern Sydney. But you can get them elsewhere. I mean, there's a disease that I was studying on Flinders Island spotted fever, which is also a tick-transmitted infection. And So they're all over the place actually. And then in the tropics, you've got scrub typhus. And then the other thing I should mention, because we're talking about Q fever as well, in the rural and regional parts of Australia, where there are a lot of sheep, cattle, and even goats, especially goats, they can have Q fever and they can excrete it, and it can blow in the wind, and you can inhale it. So rickettsial infections are important, some of which are tick-bitten, flea-bitten, mite-bitten. Some are inhaled, like Q fever. So Q fever is something that should also be remembered, although it's not strictly a rickettsial disease from a truly microbiological point of view, but it's present in ticks. You can get it from a tick bite, and it's grossly underdiagnosed because people don't think of it. Doctors don't think of it.
Now, you mentioned it before about returned travellers. What specifically regions are we worried about when people return to consider rickettsial disease?
Overall, it's definitely Southeast Asia. We see cases from Thailand, from India, Sri Lanka, Bali especially, probably because so many people go to Bali. And a lot of them live in very sort of shonky accommodation, the backpacker type, where they're exposed to rodents, PNG, some of the Pacific Islands, sometimes the Philippines, China we've had cases from. So definitely Southeast Asia, and that tends to be scrub typhus. So that's the nasty one. So it's important to diagnose that, or at least think of it. Other return travellers are from Europe, North America, and Southern Africa is actually quite common too. You've probably heard of African tick typhus. Well, that's actually a rickettsial infection, and people who go on safari in Southern Africa and Eastern Africa often get bitten by a very aggressive tick there. We don't have this tick in Australia, but it loves biting people, and they come back to Australia because the incubation period's about a week to 2 weeks, and they get sick in Australia. And if they don't mention to the doctor that, I've been on safari in South Africa, he or she may not think, it could be African tick typhus. But if you look, you'll find an eschar. So it's definitely worth looking. But it takes time because patients got to take off all their clothes. You've got to look in private parts, and probably just as easy to think could be rickettsia and give a diagnosis based on clinical presentation, epidemiology, and it's well worthwhile sending a serum off to the laboratory as well to confirm the diagnosis, because then if you aren't right, it's not rickettsia, or if you are right, you've got confirmed. Oh yes, I've given the right treatment.
We started off this episode talking about Rocky Mountain spotted fever. Is the US travel a consideration?
Yes, it is. It's not. It's called Rocky Mountain spotted fever, and it's caused by a very virulent rickettsia, actually, a very nasty one. It's the one that killed rickets, and it's actually found all through the Americas now: North America, Central America, and South America, and we see it occasionally in return travellers. But you only see it in people who've been exposed to the ticks. So people that have been sort of bushwalking and camping and doing natural activities. If you go to New York, you probably won't get it.
Look, let's just draw a breath for a moment and come back to the last part of our interview. And while we're doing this, I'll contact Tourism Australia, because we get bad press down here that everything kills you. Spiders. We can at least say our ticks pretty much don't.
No, we've got very nice ticks and very nice rickettsia. If you want just a mild infection, do come to Australia. The trouble is our Australian doctors may not recognise this rickettsia. And you may get penicillin. You may get penicillin instead of doxycycline.
Professor Stephen Graves continues to be with us here on This Medical Life, and in this part of the episode we want to turn our attention to testing for rickettsial disease. Stephen, I'd like to start with this one. Why did you set up the Australian Rickettsial Reference Laboratory, ARRL?
As my registrar project, when I was doing my fellowship with the College of Pathologists, I was asked to look at this undiagnosed illness on Flinders Island, which the one doctor there, Dr. Rob Stewart, called Flinders Island spotted fever because the patients had fever and spots. but you could never get a diagnosis. Every laboratory sent it to, nobody could diagnose it. So my supervisor said to me, Stephen, your project is to work out what this is. So that's what I did for a couple of years, and that's how I got interested in rickettsial infection, because it turned out to be a rickettsial infection. Then I realised there was no laboratory in Australia that actually specialised in rickettsial infections. So I thought, well, I'll set up my own. So that's how it happened.
We've mentioned a number of different species of Rickettsia. How many species are there?
It's somewhere between 30 and 35. But, the fact of the matter is, what's a species when it comes to bacteria? It's arbitrary. So you've basically got three important rickettsial species. You've got the spotted fever group, which are broken up into a number of different species, but they're all very closely related. They all cross-react serologically. You've got the murine typhus, the one that's transmitted by the rodent flea feces. And then you've got the scrub typhus one, which we call Oriental Tsutsugamushi, was first recognized in Japan. Tsutsugamushi is a Japanese word, I'm told, that means something small and dangerous, and refers to the little red mite that people recognize. If you got bitten by that little red mite, you come down with an illness. And this was in the sort of 1850s, 1860s. So we've still got that name, Tsutsugamushi. So they're the three important species. But as far as the doctor's concerned, just diagnose Rickettsia/typhus and just start doxycycline, because that'll help a lot, and send a serum to the lab for diagnosis.
How do we actually diagnose? Because we refer, even in large laboratories, to specimens to yourself. And is there an ability to culture, or is it PCR or serology? They're all options, but how do we diagnose infections?
Look, the main way is serology, because we look for the antibodies. We do a test on the patient's serum to see if they've got any antibodies to Rickettsia. And it's a good test. It's called a micro-immunofluorescence assay. It's not done very well in many laboratories, I hate to say, but fortunately most of them are referred to us, so we specialise in it. But the other method's culture. It's not a diagnostic method at all, because it's far too slow. And the Rickettsia die quite quickly in transit. So unless you get a sample before antibiotics and it gets to our lab quickly, we won't be able to grow it. PCR is an option, but most labs don't have it. I think we're the only lab in Australia that has any PCR testing for Rickettsia. So serology is the way to go, but there's a couple of big weaknesses with serology that doctors should be aware of. Firstly, it takes at least 1 to 2 weeks to become positive. So when the patient's actually sick, they will be seronegative. So if you take a serum then and get a negative result, that's a false negative, because the patient has got Rickettsia. If you take a follow-up serum in a week to 10 days, it'll be positive. And that's called seroconversion. We go from a negative serum to a positive serum, confirms the diagnosis as Rickettsial or Q fever, whatever the case is. The other problem about serology is, and this is not such a big problem in Australia, but in more countries where there's a high endemicity, the patient can have antibodies left over from a prior exposure a couple of years ago. So your acute serum will show antibodies, but they're not the antibodies related to the illness that the patient's currently got. They haven't appeared yet. They'll come in a week to 10 days. So you can be misled into thinking the patient's got a rickettsial infection because they've got antibodies, treat them, but in fact they've got a Staph aureus septicemia or God knows what, you see. So serology is a bit tricky, and you need a good lab to do it, and know what the pitfalls are. But it's actually the only really practical way of making the diagnosis. And I do recommend getting a diagnosis, because if you're treating without knowing what you're treating, it's really not good medicine.
Is there any cross-reactivity with Rickettsia serology and other infections?
There's always the possibility of cross-reaction, particularly the IgM class of antibodies. So if you get an IgM positive to anything, you've always got to look and say, could it be a cross-reaction? But generally, there's no cross-reaction between Rickettsia and other things, or Q fever and other things, but you can get occasional cross-reactions that can be misleading. Within the Rickettsia group, there's no cross-reaction between spotted fever group and the other Rickettsia. But within the other Rickettsia, the spotted fever group and the murine typhus group, there is a lot of serological cross-reactions, and sometimes difficult to determine what the causative agent is. You know it's a Rickettsia, but you can't work out what the species is from the serology. You actually have to have the microbe to do that, and then check for the genetic natures. Has it got this gene? Has it got that gene? Then we know. And if you've got the gene, you can sequence it. If you've got the DNA, you can sequence it. And you can say, oh, yes, this is Rickettsia typhi, or it's Rickettsia honii, or Rickettsia gravesii, although we don't know that that's a pathogen yet.
Now, I have to ask about that because after you have something named after you, I'm trying to work out, I know that's an honour, but also saying someone has an infection with, like, if I was to go to a doctor and say, I've got a dose of the Steve Davises, is that an honour to Steve, or is it a great thing to be diagnosed of an infectious disease?
Yeah, I don't know. That's for others to decide. I was very surprised when my colleagues put the name on the organism. The story was it was from a kangaroo tick in Western Australia, and they actually asked me. They knew we worked out that it was completely new, so they asked me what they should call it, and I suggested Rickettsia macropodi, because macropodi refers to macropods, which is the kangaroos, wallabies, that group. And I heard no more about it because I wasn't actually involved in that research. And then they turned out and named it after me. So it was actually intended as an honour, and I take it as an honour. But you're right. If it kills somebody one day, I guess it's not an honour.
What a legacy! What a legacy!
What a legacy indeed. Yeah. Ricketts had the whole group named after him. Yeah.
That's right. So you've mentioned doxycycline. Is there any alternatives to doxycycline, just in case someone has a hypersensitivity reactions or is allergic?
Yes, there is. The alternative is azithromycin. Azithromycin works quite well. And then further down, probably cotrimoxazole is quite good for Q fever. Not the best drug. Doxycycline is good. And ciprofloxacin works okay with Rickettsia infections, but I don't recommend it for Q fever. So really, it's really much better to use doxycycline if you can. And even though the patient might have a side effect, if it's a mild one, stick with it, because you only need about 3-4 days of treatment. Unless the patient's got chronic Q fever, in which case you need an infectious disease physician and surgeon to be involved. That's a lot more complicated. But just acute Q fever or acute rickettsial disease, at the most 7 days of doxycycline should be fine.
Now, is there any important lessons that you've learnt with all your time with rickettsial infections that you wish you had known at the start when you started the RLL?
Well, it was very much a dormant field. Almost nobody knew anything about it. That's why I felt there was a need to have a reference laboratory to help. So the thing that really has struck me over the years was how much ignorance there is about rickettsial diseases, including Q fever. Q fever is it's the number one zoonosis in Australia, would you believe? And we've actually got a vaccine for it. It's called QVax. And so many doctors don't know about it. We've estimated that only about 10% of people who would benefit from the Q fever vaccine actually get it. So it's a shocking failure in public health, all due to a failure in education of doctors. And of course, all areas of pathology are undercovered in the medical course. Don't get me started on that. And in particular, microbiology. So a lot of doctors, come out graduating not knowing too much about infection, to be quite honest, and very little about microbiology.
That is rather sobering as a note to almost end on. Perhaps the last thing I would ask you, Stephen, is there any final comments that you have about rickettsia for our listeners, both GPs and any members of the public who are listening in?
I think for doctors, it's just think about it. If the patient could have a rickettsial infection, put it on your differential diagnosis. If the patient's not that well, you could wait for a lab result. But if they're very unwell, start doxycycline. If they've got a pneumonia, if they've got hepatitis, if they've got encephalomyelitis, something like that, and they're quite sick, don't forget to start anti-rickettsial treatment if it could be on the differentials. In terms of the public, the best thing is to avoid getting bitten by these little critters that carry it. And I might mention it's recently been found that cat fleas carry a rickettsia as well. So even your friendly cat at home, keep it free of fleas. I can't say flea-free, it's too difficult. Keep your cat free of fleas and it won't get rickettsia. But we had cases in Melbourne of people getting infected from the fleas on their cat They're all over the place. It's just that people don't know much about them.
Yes. Well, look, Professor Stephen Graves, thank you so much, not only for joining This Medical Life, but for covering this topic of rickettsial disease, because now we can tick it off our list.
Oh, very good. Thank you very much.
This Medical Life is recorded in the Talked About Marketing Studios in Adelaide. For show notes and more information about the podcast, visit thismedicallife.com.au. You can contact the hosts on social media. Dr. Travis Brown can be found on X. His username is @Dr. Travis Brown. That's Dr. Travis Brown. And Steve Davis can be found on LinkedIn. Go to linkedin.com/in/TheRealSteveDavis. This has been a PathNotes Proprietary Limited production.